Why is that wanting to chatter? Got like no stick out here. It's not a heavy cut. What the heck is going on? Hello Internet, my name is Quinn and this is Blondihacks. We're back on the PM1 steam engine today and we need to do an operation that you don't see very often. It's called spot facing. There's a lot of different ways to do it. We're going to pick the best one for us right now. Strategy time again. So we've got the hole made for the piston rod and next we need to machine this end here. And the drawing calls for that to be round so it'll mate with the cylinder. And that's what it's supposed to look like right there. This is a spot facing operation, which is a fancy name for a very shallow counter bore. So we've got a slightly tapered surface here. It's tapered, of course, because of the draft of the casting. And so we need to make it flat and it needs to have a round bottom. The diameter of this is 1 5/8, 1.625 inches, which is not a super convenient diameter. That doesn't match like an end mill or something that I have. And we could just machine this flat and it would be fine, but I want to make it nice. I want to make it round like it's supposed to be. So I have a couple of ideas for that. First idea I had was to do it as a genuine spot facing operation. So I would fixture the casting on the cross slide, something like that. And then I would make a tool that would look a lot like a line boring tool. It would be a shaft that would go in the chuck and in the tailstock, and it would have a small piece of tool bit like this, and it would spin like so. And the idea is you make a shaft that fits through the hole there, and then it has a particular grind on the tool bit, look a little bit like a lawnmower blade, and you spin this guy and you face off the surface. So you make this tool bit grind such that it grinds a surface of the exact diameter that you want in one pass. That's how real spot-facing machines work. Here's the problem with that plan. This hole here is not very big, and the tool bit I would have to make is also not very big, and the distance that the line boring rod would have to go through is quite long. So the rigidity of this whole setup would be pretty poor. And I really rather doubt I'm going to be able to do a 1.625 spot face with such a small shaft over such a long distance. It's really tempting to try that because it would be a cool operation on the lathe, but I really don't think it's going to work. I spent a long time thinking about this, trying to come up with some way to make it work. Like, was there a way I could do it in multiple passes, you know, extending the tool bit a little bit each time, or design some kind of a spot-facing tool that had an adjustable depth of cut, or, you know, I really wanted to make this work because it would have been a really cool operation. But I had to give in, and I'm going to do it a simpler and more practical way. Instead, what I'm going to do is I'm going to stand it up in the mill, like so, and I've got a piece of steel here, and I got my tool bit, and I'm going to make a one-time use fly cutter, and it's going to be exactly the diameter that I need. So I'm going to make a little miniature fly cutter that has the tool bit at exactly the 1.625 diameter that I need, and then I'm going to take advantage of the fact that the spot face has an open end on it. It's not completely embedded in some other surface. So what that means is I can take my fly cutter and I can come in from the side like this, and I can just come in to the same mark on the DRO each time, doing multiple passes, working my way down, and my stopping point is centered on my hole right there. And if I locate that hole really well and I'm careful with the DRO on each pass, then I'll end up with a perfectly centered spot face of the correct diameter. Now you could also do this with a boring head. Boring heads can be used as a variable diameter fly cutter with the right tool grind. However, boring heads take up a lot of vertical space, and this is a very small hobby mill. So with the tall casting in there, I really only have a couple of inches within which to create some sort of tool that can do this job. So that's why I'm going with the little tiny fly cutter. I'll start by chucking up this piece of scrap in the 4-jaw, and I'm doing it in the 4-jaw because there will be 2 separate setups required here, and well, also just because the 4-jaw happened to be on the lathe and I don't want to swap the chucks twice, even though these first few steps would be a lot easier on the 3-jaw. But I will start by facing the end, as is tradition. Times like this, I'm glad I sprung for the power cross feed. Look, Mom, no hands. This last part should be especially satisfying as I face off that old drill cone from some previous part that was made from this stock. Now I'm going to flip the part around, and I want to make the other side parallel to what we just faced, but I need it to be off the surface of the chuck a little bit. So I've got some parallels in there to give it some space. This would be a great use case for a lathe spider if you've ever seen one of those, but I don't have one. So the parallels work just fine. You can tap them in securely against those, and the part will be parallel to the chuck face. Just of course don't leave the parallels in there, that would be very bad. The reason I need it off of the chuck face a little bit is because I don't have enough length of material there to create the features that I need if the part is seated fully against the chuck face. There's a little bit of an art to this tapping in method, because if you tap it in too firmly, the parallels get jammed in there and you can't get them out. So you kind of have to tap it in so that it's about the same friction as a feeler gauge, so you can still remove it, but you can trust that it's fairly parallel. This isn't going to be 100% perfect, but it's certainly good enough for what we're doing here. So now I can face off the other side, and those two sides will be parallel. Now I'm going to square up the tool post here, and I'm going to make the mandrel of the fly cutter. I touched off with a witness mark there on the depth that I want, which isn't critical as long as I have a good chunk there that the collet can grab. You can see there why I really needed those parallels in there to space it off the chuck, because I really don't have enough room on this piece of scrap to get all the way in there. Now this is cutting very well, but you can hear there's a kind of a noise in the cut that's right on the edge of chatter, like it lives next door to chatter, and you know, they've talked over the fence a little bit, and maybe it's kind of interested in chatter and it's thinking about buying chatter dinner, but it doesn't know how chatter would feel about that, but it's not quite there. And this took me a little while to figure out what was going on. I messed with my setup a little bit and I fooled around with it, but it was doing the job, so I just kind of kept rolling with it. Here on the finishing pass though, you can see what's wrong and where the chatter is coming from. The grind on this tool isn't quite right. You can see that when I put the nose radius on it, I messed up the front clearance a little bit. So when the tool is squared to the work like this, you can see that it's actually cutting a little behind the nose radius on the flat section there. So I basically accidentally created a shear tool. So it's getting a great surface finish, but it can't handle very much depth of cut at all, or it wants to chatter. So I just swapped this tool out for a different one later on here in this part. And I'll regrind that tool later. I just need to increase the clearance on the front edge of it there. Okay, let's see how I did. I'm aiming for 750, so it'll go in a 3/4 collet. And I'm about a thou over, but it'll still fit in the collet, so that is okay. So I will chamfer that edge and just make sure that it's going to go in a collet, and indeed it will. I think that's going to work out just fine. Now I'm going to flip this part around and do the other side of the fly cutter, but once again I can't push it up against the jaws because I need to be able to get right up there with the cutter. But now I can't get parallels back there, so how do I make sure the part's running true with the lathe and the front face of it is square? I start by dialing it in just like you would with any other part in the forejaw, and then I move the indicator over to the front face and I dial that guy in as well. So the front face should be reading no runout if it's square to the lathe, and I have a couple of thousandths there, so I just tap it in, and I'm tapping on the sides. That's a little bit counterintuitive because you would think you would want to hit it on the face because you're trying to square the face, but if you do that, you're just going to push it further into the chuck and it's not going to straighten the part. Now I can do a couple of passes on the outside diameter just to get that running true. You can see I've switched out the tool there, as I said, and this one is cutting much better. You can see that it's cutting on the nose radius instead of behind it. And then a little chamfer there will finish it up. Now, did I do this in the minimum possible number of setups on the lathe? Probably not. I swapped it back and forth twice end for end, which was probably a waste of time. I'm sure if I'd planned this a little better, I could have done it more efficiently, but the job got done. Now I'm just going to deburr that backside there with a file because I forgot to do it when I had it in the other setup. You really want to avoid improvising in machining. It really pays to plan ahead a bit. Now I need to make a hole for the tool bit a very precise distance from the center in order to make sure that it cuts the radius that I want. So I need to get it perfectly aligned on the mill spindle, which, because it's designed to go in a collet, is actually very easy to do. I just put the fly cutter body in the collet, pull the quill all the way down till it's on the table, clamp it down, and then zero the DRO right there, and then loosen off the drawbar, which I did by tapping the drawbar wrench to make sure that the drawbar loosened before the part twisted on the bed there. I'm kind of shocking the drawbar loose before it tries to turn the part. And then I pull the quill off, and there's our part, perfectly centered on the spindle. Now we need to get with the mathy math because I need to figure out where to put the hole for that tool bit. And the trick is that the outer front corner of the square tool bit has to be on exactly a 1.625 diameter so that it will cut our feature properly. That means that the hole that I'm going to drill with a round drill bit, mind you, inside that square has to be at a specific radius, but also a little bit below center line because the front edge of the square tool bit has to be on center. So here's the math that I did to work that out. And luckily, because we're centered on the spindle, the DRO is going to get us to that spot quite easily. Next, I want to double check that my drill is going to go into the T-slot of the mill table here and not hit the mill table as I hoped it would, and indeed it does. I got a little lucky there on that positioning and didn't have to redo that. I start by center drilling that, and I'm drilling to a little less than the size of a circle that would fit inside that square for the tool bit that we need. That's really it for the machine tool work on this thing, believe it or not. So I'm just going to deburr that hole. Okay, that's looking very nice indeed. I think we're done. We'll do a little test fit with the tool bit here, and oh, right, something square peg round hole. Okay, we need to make this into a square hole. The perfect tool for this job would be a square broach that I could use in my arbor press. Unfortunately, broaches are very expensive and I don't have any. So I'm going to do it old school. Here's a file, and this file is smaller than the square hole I need to make. So here we go. I'm just going to file that round hole square. And yes, this takes a while, and yes, your hands are going to be a little sore by the end of it, but it's character building. The key here is to check your work often as you file to make sure you're not getting crooked and that you're not introducing taper. And that's really easy to do when filing because the file can easily bend or shift off of flat as you go. But after about an hour of character building, we have a pretty decent looking square hole that I believe my tool bit should fit into. And look at that. Very nice. I think that might just work. Okay, I lied when I said we were done with the machine tools because now we need to put a set screw in there to hold that tool bit in place. So I'm going to mount the body of the fly cutter in a 5C collet block here, and I'll put that on a 1, 2, 3 block to get it up off the table since the vise is over on the bench because it was in the way of our steam engine project. And I'm just squaring this up by eye and by feel. It really isn't that important. And I'm going to put a flat spot on here with an end mill because normally when you drill into the top of a convex surface, you can just center drill carefully and that will put a dimple in there that'll keep the drill bit from wandering off the curved surface. However, when you're drilling offset on a curved surface like this, not on the dead center of it, even a center drill is going to want to wander off that surface. So make a little flat spot with an end mill first, and then center drill on the flat spot, and then come in with the tapping size. Then I can come in with my spring-loaded tap follower and set up to tap that hole. This is, I think it's 832. I don't know, it's whatever set screw I found in the bin. And I just eyeballed the location of this threaded hole to make it roughly centered on the square hole there. As long as it's in the square hole and touching the tool bit, it's going to work. So we'll do a little test fit here now. Tool bit goes in. Set screw goes in, and it's going to work, except my set screw is too long and it has a dog point on it, and both of those things mean there isn't a lot of thread engagement. So I thread it into a piece of scrap, put a jam knot on the back, and grind it flat on the grinder. And now I have an itty-bitty set screw. Now undo my jam nut there, and thread that guy in there. And that looks like it might work. So you can see how it's going to spin around and be a fly cutter. Now it's time to grind that tool bit. Obviously it's a lot too long and it has no grind on it. This is a raw piece of high-speed steel that actually a viewer donated to the channel. So I mark the cutting point so that I don't lose track of it, and I just need to grind clearances falling away from that cutting point in every dimension. What's interesting is that this ends up being standard right-hand turning tool geometry because the tool bit is vertical. Normally, fly cutters, the tool bit is lying sideways, and so you end up requiring left-hand turning tool geometry, which is sort of annoying because it means you can't reuse your tool bits between your lathe and your fly cutters. But in this case, we can, so it's a very tiny tool bit, which made grinding a bit of a challenge, but it looks like that is going to work out. And I'm just going to mark the length now and cut it to length with a grinding disc on the Dremel. Here's a pro tip when using a Dremel like this. Make sure to finish the cut such that the extra piece that is being cut off lands perfectly on the bench. Now this takes practice, but if you're really skilled with this tool, you can get it to do that every time. What? Why is everybody laughing? What? I could make it do that again. And I don't need to show you, I don't have anything to prove. Get out of here, this is my shop. Now, where was I? Oh yes, this tool bit. So next I gave it a little stone hone on the stone, and sharpened it up. It's looking pretty decent. You'll see that I didn't grind the side clearance there all the way down, mostly because I was lazy, but that's okay. This cut is not very deep, so that will suffice. Back into the fly cutter it goes, and the fly cutter goes into the mill, and let's see about giving this thing a little test drive. So I think that's gonna work. You can see how the outside point there is gonna be doing the cutting. So here's a piece of scrap, and I'm gonna do some test cuts here. So the piece of scrap has kind of a boss there that's proud of the top surface, which will work out good because it'll give me a chance to test it out. So far so good. It's cutting like a fly cutter, which means it threatens to chatter if you get too aggressive with depth of cut, and you need to feed very slowly. So I'm doing, I think the most I did was like an 1/8 thou pass here. It's important that my test cut is deep enough that I have enough meat to measure the straight sides of the cut and not catch the fillet made by the nose radius of the tool. And this is cold rolled mild steel that I'm cutting with it. Surface finish there is pretty decent. I think it could be a little better. I'll experiment with that. I made one more pass with a little bit more speed and just a 2 thou depth of cut, and now the surface finish is excellent. But let's see how we did dimensionally. I'm measuring at the widest part there where the cut is straight and trying to get a sense of it. And you can see that we are at 1/646. So we're actually 20 thou over on the cut, so probably my filing was a little bit imprecise, but that's actually good news for us because I can make the diameter of the cut smaller just by grinding the outside of that tool bit down a little bit. So I blued it up and marked a 20 thou line on the edge and then ground that side back down to that line. So another test cut. And let's see how we did this time. Again, making sure I went deep enough for this measurement. And we are at 1/621. So we're actually 4 thou under now, and I think that's going to be okay. Here you can see the two test cuts, one of them being 20 thou smaller than the first one. That worked really well. Now, if I wanted to chase that last 5 thousandths, there's a couple of things I could do. I could, of course, regrind the tool and, make a new cutting edge on it that was 5 thou wider. A better way, perhaps, would be to grind down two sides of the shank of the tool to make it a little smaller than the square hole. And that would allow me to shim it with some, 1 thou shims, 2 thou shims on either side and move the tool then radially and change the diameter of the cut. But I'm not going to do any of that. I actually like that it's cutting a little undersized right now because this is the shape of the cut that we're going for on the final casting. It's coming in from one side and leaving a curved arc here on one edge. So what that will allow me to do is if I need to make it a little bit larger, if that 5 thou is a problem, then I can just move my cutter up and down 2.5 thou and widen this cut out a little bit. And I'll just end up with a slightly oblong curve out here that honestly you probably won't even notice, and it's going to be behind the cylinder anyway. So I'm really happy with how this tool worked. Let's try it on the real thing. New in the Blondihacks store, stainless steel insulated beverage tooling. Extremely repeatable, compatible with metric and imperial beverages. Also good for storing cutting oil. A quick double check on my angle plate to make sure that it's still trimmed in, and it looks very good. So now I can get my casting fixtured to it here. But a quick side quest back to the lathe for a second. I'll explain why here in a moment, but I've got some aluminum here that I'm going to turn down. I'm using this tool that has a chip breaker grind on it. I've had it in my drawer for a while, but haven't tried it yet. I thought I'd give it a shot on aluminum to see if it breaks a chip better than my other tools do. And it does break a chip okay, but the surface finish on it is pretty dreadful. So I'm not sure if I like this tool very much. And in fact, as we get further down, it stopped breaking a chip anyway. Yeah, that's totally rubbish. Okay, back to my traditional aluminum tool, and this is turning very nicely. That is a beautiful finish, and it breaks a chip, frankly, no worse than that chip breaker grind did. So I still haven't found the magic bullet for breaking chips on aluminum, but that's okay. We're getting the job done one way or another. I'm turning the OD to 3/4 because that's going to go in a collet in the mill, and then I turn a narrower section at the end to go into the hole in the end of our casting. And I'll do a chamfer on here because we're going to do a test fit, and any burr would mess up that test fit. And the first test fit was a failure, so I'll take just a hair more off and try it again. I don't know exactly what the size of the hole in the casting is because it was made with a drill through a bushing, so I just took off like a half a thou at a time until it fit, and that is a perfect fit. Out of curiosity, let's see where we did land. That's 313.5, and that was drilled with a 5/16 drill, so it's about a thou oversized, which is about what you expect with a drill. Now we're all set with this little mandrel tool thing, so we can part it off. Yahtzee. Side quest complete. We can resume our setup of the casting. And this needs to be really, really vertical because that's going to dictate how square the cylinder is mounted to the engine relative to the piston axis and the crankshaft and so on. So it's very important that we get this as perfectly set up as we can. So I'm indicating down the length of the entire inside edge of the bearing slides there, and that's pretty much dead nuts on 0. We've got maybe a 1/10 somewhere in there, but that is about as good as I can get it. It took a while to get it set up that well, but it's going to be worth the effort. So now I can clamp it in with some brass shims to protect the surfaces. And just for giggles, I did one last check on the front of the bearing slides, and it's about half a thou off. So I got worried, took the clamp off and measured the entire length, and yeah, it's a 1,000th off of vertical in that dimension. So how did that happen? So out of curiosity, I indicated this angle plate. And would you look at that? This angle plate is a 1,000th off of square. So that's not great. I want to do better than that. So I tore it all down and set about fixing this angle plate situation. Step 1 is to go over my table with this precision ground flatstone. This is from Lance Balsey over at 26 Acre Maker. He makes these guys, and this will remove any nicks or dings in your table and, well, turns your table into an air hockey table, as you can see here. I'm having a little fun. These stones really are quite amazing. They basically make any surface into an air bearing. I stoned the angle plate as well, made sure everything is clean, and then I set it back up again and indicated it again, and the error is still there. So nothing left to do but to shim it. So I got a 1 thou shim, and we'll see how that affects the angle here. It's not going to be 1-to-1 necessarily. That 1 thou shim is exactly what it needed. That is dead nuts. That's beautiful. Imperial thumbs up. So I redid my setup with the casting, and then I measured the bearing again to make sure that was the only source of error I had, and it looks like it was. Imperial thumbs up once again. Okay, in goes the little mandrel that we made, and now I can use this to line up the spindle on that hole. So this is really just trial and error, just applying very light pressure with the spindle and wiggling the table around until it slides in perfectly. Now we can swap out to a 3/4 collet and mount up the little fly cutter that we made. So the spindle is perfectly centered on that hole, and that's the stopping point of the cut, since we want the final diameter that we cut to be centered on the hole. So I then move it off of the casting, I dial in a little bit of depth of cut, and I move it back into the casting, stopping at 0 on the DRO. This takes a while because at first few cuts nothing really seems to happen because we're cutting into the angle there of the draft from the casting. So there's quite a bit of angle. It's really only the last couple of cuts that are doing a full depth all the way down. But you can see here this seems to be working pretty well. I'm cutting dry here. You always cut cast iron dry because it is self-lubricating. It basically spits out graphite as you cut it. There's so much loose carbon in it. Now there's 2 important dimensions here. The thickness from the gland plate across to this surface that we just made. And so there we've got quite a bit of ways to go. However, there's also a dimension here that's specified in the drawing, basically the thickness of the casting area at the top. And on that dimension, we're basically right where we need to be. We don't want to go any further there. So we still have quite a bit of material to remove out of that area between the spot face and the gland surface, but we can't make that spot face any deeper or the casting will get too thin to hold the cylinder mounting bolts. So what that means is we got to set it up back in the horizontal position that we used before to cut the gland plate surface and make the gland plate area thinner. So this is a setup that you may recognize from a previous video in this series. So this is the same operation I did there. And I went, in fact, all the way down this time to get rid of those hooks while I was in there. Did a little bit nicer job than before. And then just deburr that and clean it up, and that's looking pretty decent. So the gland nut is going to fit right in there, as you can see. I think that's going to work. Now I'm just going to deburr that hole, again using my Trick Inside deburring tool. There's a link to this down below. It's by Noga. It's a great tool. Hashtag not sponsored. So far so good. Yeah, that's looking really good. The surface finish on there is excellent. Very happy with that. And my dimensions all came out pretty much right on. I think I'm within 1 thou on every dimension that I could find to measure. So far so good. I think this was a successful spot face. This was once again a bunch of yak shaving. I hope it was enjoyable for you. That is all the time we have. Thank you very much for watching. Throw me a little love on Patreon if you like what I do, and I'll see you next time.